Hello and welcome. So today we are going to discuss some application layer protocols. Two of the most popular protocols on application layer are DHCP and DNS. So we are going to discuss how these protocols they work and what kind of attacks are usually launched on these two protocols. So the first protocol is Dynamic Host Configuration Protocol, also known as DHCP. Before we go into the discussion of DHCP, there are two important questions. One is that how does a host gets an IP address on the network? So if you have a computer system or a mobile device that you get connected to a wireless router or the Ethernet switch, for example, then how does your host gets an IP address? And then the second important question is that how does the network gets an IP address for its network part? So the answer to this question is that um, on the networks, usually nowadays we have DHCP. Previously, we used to have the Bootstrap protocol, which used to do the same thing of assigning IP addresses to the hosts. But nowadays we have a dynamic host configuration protocol, which dynamically assigns IP address. So it's basically a server that is on the network. It has a pool of IP addresses, and it basically, whenever a host comes on the network and requests an IP, this server is going to dynamically assign the IP address. Another way of assigning the IP addresses to the hosts is that you can also manually configure it or hard code it. For example, the system administrator can go ahead and change rc.config file in order to assign the IP address. Similarly, in Windows also, you can statically assign IP addresses. In various Linux versions, the file may vary where you need to change, assign an IP address to the host. And then this IP address, it basically has two parts, as we discussed in the network layer. Each IP address has a network part and a host part. So it actually depends on the subnet mask, which decides which part is the network part and which part is the host part. So the goal here in the DHCP protocol is to dynamically assign the IP addresses, because statically assigning IP addresses will usually it's cumbersome. It's a difficult process. The administrator has to manually assign static IPs to each host. So when you have a bigger network, it's practically not feasible that you'll be using static IP addressing. So instead of that, we have the protocol like DHCP, which will automatically assign the IP addresses to the host. Now, the DHCP, it can basically lease the IP address to the host, and this lease is for a specific time period. And after that, when the lease expires, it can automatically renew the lease on that IP address to the host. It also allows the reuse of the addresses, which means that unlike in static IP addressing, where a host has statically taken over an IP address, DHCP, when the host leaves and the IP is free, it can also assign it to other hosts, whoever is coming in joining the network. And secondly, it supports all the mobile devices, systems, devices that require IP addresses who are joining and leaving the network. To give you an overview of DHCP, normally there are four types of messages which are exchanged in the protocol. I'm also going to show you these in a more graphical way, how these messages they work. So the host normally, when they join the network, they broadcast a message called DHCP discover message. However, this message is optional. The second message, the server responds back by offering an IP address, DHCP offer message. And the third message, again, the second message is also optional. The third message is that the host will officially request that, okay, the offer that you made, I need this IP address. And the DHCP server will send a DHCP acknowledge message, which is basically the message which contains the IP and the lease time and everything. And after that, the host will basically be assigned that particular IP address. So this is just an example of the DHCP server in the network. Normally, the DHCP server could be a standalone server like Windows Server 2008, 12, 16, 2022. It could be a Linux-based DHCP server as well that can lease the IP addresses. DHCP can also be configured on the routers. So the router will become a DHCP server and will start assigning IP addresses to the hosts. So in this scenario, you can see here that we have a wireless router as well as we have a DHCP server as well. So in this case, for example, you can see that this network, these hosts, they have 223.1.1 IP addresses, and then it has 1.2. And similarly, these hosts, they also get the IP address of their network. And then on this side, you have two networks. So 223.1.2, 223.1.1, 223.1.3 networks. You may also have noticed that when you are at home, there's no DHCP server at the back end, but your wireless router, it normally acts as a DHCP server. So it's up to you whether you want the wireless router to assign IP addresses, which will of course be of the different range. So because it's a separate wireless local area network, or you can also configure the wireless router in such a way that the DHCP server will always assign the IP addresses through the wireless router. So this is a DHCP client server scenario where you can see that the client is arriving, means joining the network. DHCP server is already there on the network with this IP address. So the first message that comes from the client which is joining is a broadcast message, which contains the message like, is there a DHCP server, which means that he's asking uh, to know if there is any DHCP server that exists on the network. So if you look at this, the contents of this message, you can see here the source IP is 000 because this particular host doesn't have an IP address yet. And then you can see here that the destination address is 255.255.255, which is basically a broadcast IP. And this is the source port. This is the destination port. Your IP address, I mean, this doesn't have any IP address, this client. So this is also 000. And then this is the transaction ID. Now, this transaction ID basically keeps track of the messages that are being sent by this client. So this message is a DHCP discover message, which is coming from the client. In response to this message, the DHCP server will respond back that, okay, I am the DHCP server, and here is an IP address that you can use. We call this DHCP offer. So this is the initial offer where the source or the server will send his, you know, the address. You can see here your address means that it is offering 223.1.2.4. The source is the server itself. So the source IP you can see here. The destination is a broadcast because still the server doesn't know where this client is and it doesn't still have the IP address. So he's making an initial offer. You can see the transaction ID is 654 because this transaction ID is keeping track of these messages. Sorry. And then you have the lifetime or which is 36 seconds. Now these two steps can be skipped. Like I said, these are optional. And these are optional because if the client remembers and wishes to use the previous IP address that was allocated, it can skip these two messages. The third message comes from the arriving client. It's a DHCP request. Again, it's a broadcast, and he will basically say that I would like to use this IP address. So in this, you can see the source address, still he has not taken it until it receives a confirmation from the server. The destination is still a broadcast, and the IP address that was sent to him is 223.1.2.4, means he's telling the server that I want to take this IP. Now, this is a new transaction message, so it contains 655 as the transaction ID, and the lifetime is 36 seconds. The DHCP server will receive this message and he will understand that this user, he wants to take this IP address that I offered. So he will send a reply back saying that, okay, you have got this IP address. So now you can see here the source address is 223.1.2.5. The server IP, the destination is still a broadcast because he has not been assigned the IP yet. And then his IP address that was offered initially and confirmed by the client. Is there the transaction ID is 655 because this is the same message of this transaction. I mean, second message of this transaction. And this is the lifetime or the lease time, which is 3600 seconds. So once this client receives this, the IP configuration will be done and the client will be on the network. All right, so now let's look at what kind of attacks are possible on the DHCP protocol. Um, so the first attack that is possible on the DHCP protocol is known as DHCP starvation attack. Now, DHCP starvation attack is basically kind of a denial of service attack, where the attacker will send or broadcast forged DHCP requests, and he will try to lease all the IP addresses from the DHCP server. And then once the server doesn't have any IP address left, then obviously the other legitimate users or clients, they won't be able to get an IP address. So in this scenario, you can see the attacker is sitting here and he's sending fake MAC addresses and asking that, okay, I need an IP address, I need an IP address, I need an IP address. So these messages, then they will be passed to the DHCP server. The DHCP server will think that these are legitimate requests. He will keep assigning these IP addresses against these MAC addresses. He will keep accepting it, but basically these users, they don't exist. So what will happen that the DHCP server will eventually run out of the IP addresses. And when this user wants to get an IP address, he won't be able to get any IP address. So this is what we call as the DHCP starvation attack. So you can see there are plenty of tools that can be used to launch DHCP starvation attack. You have Hyena, DHCP starve, Gobbler, DHCP pig, and so on. Another type of attack that is possible is called the rogue DHCP server attack. Now, rogue DHCP server basically means that the attacker will start acting like the genuine DHCP server, and he will start leasing the IP addresses. Now, how this is possible? Well, this attack is possible in combination with the previous attack that we discussed, that once you starve the DHCP server from the IP addresses and he has nothing else, to offer, then he becomes the DHCP server and will start leasing IP addresses to this client. So what will happen is that this user will get the DHCP IP address along with the gateway information and everything. And since the rogue server or the attacker will give him the gateway as his own IP address, so all the traffic of this user then will be forwarded to the rogue server. And then the rogue server or the attacker will basically forward these requests to the internet. So it's kind of a man in the middle attack where he is actually able to capture all the traffic going through his system for all the users on the network. So this is second type of attack. Another way of launching this attack is also possible that the attacker can launch a denial of service attack. So obviously DHCP starvation is one way, but you can also make this server busy with some kind of other denial of service attack where the server is unable to reply, and then the attacker will become the rogue DHCP, and the same attack will continue the way I just explained. So the question is that how do we defend against the DHCP attacks? Well, one of the ways to protect or defend against DHCP attacks is that you can enable port security on the switch. So we have already discussed in layer 2 how the port security can be configured. You can see the commands here where you basically allow maximum 1 MAC addresses on the port, and if the MAC address changes, the port will be disabled or become inactive. So here you can see that we are defining that the maximum number of MAC addresses allowed on a port is 1. So when the attacker is launching a DHCP starvation attack, multiple MAC addresses are coming from the same port, so the port security will basically protect it. Now it's up to you how you want to implement the violation. Here you can see that the violation is to restrict. You can either shut down the port, you can restrict the port, whatever you want to do, the level of security can be implemented here. So restrict basically means that it is going to log and then drop these packets. If you restrict it to if you change this violation to shutdown or disable, then it will basically disable the port. Along with the port security, you can also enable DHCP snooping on the switch. So DHCP snooping is a security feature that is offered by the switches, where you basically define one port as a trusted port. So wherever your actual DHCP server is connected, you can enable this as the trusted port, and the rest of the ports, they are untrusted. So any DHCP transactions that are being offered from the untrusted port, they will be denied or blocked, whereas from the trusted port, the switch will basically allow. So these are the commands that can be used for defending against DHCP starvation or rogue DHCP server kind of attacks. Now, the next protocol that we are going to discuss is called DNS, or domain name system. I think in the list of most significant protocols, DNS is also there. The other significant protocols that we discussed, that without which the communication is not possible, is BGP protocol, or Internet Protocol, IP protocol on the network layer. And similarly, the DNS is also a very significant protocol, because without the DNS protocol, the domain name will not be resolved into IPs, and then the whole internet infrastructure will sit down, and you won't be able to gain access to the internet. Now, what is a DNS? So DNS is a domain name system, which means that for example, people, they use different identifiers. They use their names, they use their passports, they use their social security numbers to identify themselves. Similarly, the internet hosts or routers, they basically use IP addresses and domain names to identify themselves. Now, the domain name is easy for us to remember as humans, google.com, facebook.com, cs.umass.edu. It's easy for us to remember, but it's difficult for us to remember the IP addresses of the server. Now, the domain names, they are for humans, whereas the IP addresses, they are the ones which are usually understood by the devices and by the routers in order to route these requests that you are making on the internet. So the routers, they have no idea of what is a domain name. So it means that we need some kind of translator in between that can translate the human readable domain name or human understandable domain name into the IP addresses. So that is where the DNS protocol is. So the job of DNS protocol is to resolve these domain names into the IP addresses, and then the routing of the packets will actually begin, right? Now, these domain name systems, they are basically the domain name system is kind of a distributed database that is implemented in a hierarchy of many name servers. I'm going to discuss this hierarchy shortly. So as I mentioned, it's an application layer protocol, and without this DNS protocol, it's difficult to communicate on the internet, and it's implemented into the application layer. So every operating system, when you install it, it has a DNS client program or process that is running. So you can easily check it in the Windows as well as Linux if the DNS service is running on your system or not. So here you can see it's an example of ngit.edu, which is the domain name that you type in the browser, and this is the IP address of the ngit.edu, which is 128.235.251.225. So either of them, if you write it in the browser, you will basically gain access to the ngit website. So eventually, every server, every web server, or every host, they basically have an IP address. But obviously, it has to be publicly accessible. So the question is, what are basically the services that are provided by the DNS? Well, one service that we just discussed, that it resolves the domain name or the host name to the IP address, right? So this is the main use of the DNS protocol. But apart from that, the DNS can also be used for host aliasing, for where the host, they have the canonical names. So you can check the canonical name of the host, and you can also check the mail server aliasing as well by using the DNS service. So if you use the tools like DNS Recon, for example, or even by using the NS lookup, you'll be able to see what is a canonical name, what is a mail server aliasing. So let me just show you quickly in the command line how you can find the this information by using programs like NSLOOKUP. All right, so you can use the Windows command prompt by running it as administrator, or you can use Linux as well. So if I write NSLOOKUP and I write, for instance, google.com, right? So you can see that I've got the reply saying that this is the domain name, and the IP address of this domain name is, this is IPv6, and then this is IPv4. So this simply by writing NSLOOKUP, it uses the DNS protocol to resolve the IP address, the domain name into the IP address. Now, if I want to find out the mail exchange servers of this domain, so I'll write NSLOOKUP, and then I'll set the type to MX, and then I'll just write www.google.com, right? So just a minute, I think I have to write google.com, not www. So now what you see here is that I can find the mail exchange servers of Google by using the NSLOOKUP. So here you can see this is the SMTP mail server for Google. This is the mail server. This is the mail server, and these are the IPv6 addresses of this. Similarly, if I want to find the name server of google.com, so I'm setting the type to NS name server, and I'll just write google.com. So you can see here that I was able to discover 4 name servers of Google. So this is how the DNS protocol can be used to find out various information about the about a particular domain. Another important service of the DNS protocol is load distribution. So load distribution basically means that you may have web servers which are basically located in different regions. Plus, you may have multiple multiple web servers. So in that case, you don't want, for example, Google is a giant organization, and there are billions of users. So you cannot expect Google to have one web server which is responding to all these requests. So they have multiple web servers. Now, the DNS protocol can distribute the load among these web servers. When a user makes a request to resolve the domain name like www.google.com into IP, then the DNS protocol will what the DNS protocol will do is that it will translate in all and bring all the IP addresses of a list of IP addresses of these web servers. And so the first IP address will be picked, and the request will be sent to that IP address. The next time when you're making this request, or some other user is making this request, so the DNS protocol will randomize this server list, randomize these IP addresses, and then some other IP address of the web server will be on top, and then that will be picked to respond to the request. So in this way, the load on the web servers is basically distributed by using the DNS protocol. Now, a big question is that why don't we just have one DNS server that will respond to all the queries? So it's a genuine question. I mean, why we have a hierarchy of DNS servers? Why we have multiple DNS servers? Why don't we have just one big giant DNS server with a lot of computational power and then is responding to all the queries? There are different reasons. One is that it could become a single point of failure. So if your single server that you have a big DNS server and it goes down, then obviously the whole network infrastructure will collapse. Secondly, there will be too much traffic going towards one DNS server, and it will be difficult, you know, to handle the number of requests. The maintenance will also become a problem because if the server goes down again and again, then the maintenance becomes an issue. So rather than that, in the DNS, we usually have the distributed kind of architecture where we have multiple DNS servers physically on different locations. So if you are sitting in, for example, Russia, so you'll be accessing a DNS server there in the Russia rather than a centralized DNS. So the queries will not take much time to travel across the world and then get the reply. So these are some of the reasons why we cannot have a centralized database. So like I mentioned, that DNS, it has a distributed hierarchical database. So you can see here on the top, we have the root name servers or root DNS. The second level of DNS, we call them the TLDs or the top level domains. So root domain name servers are also known as dot servers. And then you have .com DNS server, .org, .edu, .pk, .in, .us. These are all the top level domains. And then we have the authoritative name servers, which are basically the servers of those organizations like umass.edu, ny.edu, pbs.org, amazon.com, yahoo.com. So these are the authoritative name servers that belong to these organizations. And there is one more server which is not mentioned here, but another server should come here is the local DNS server. So apart from the authoritative name servers, we also have the local DNS servers. So for example, if you are working in an organization, they will set up a local DNS. And the idea of local DNS is that instead of sending these queries to the authoritative name server or TLDs or root name servers, if your local DNS has the record, it can actually give you the IP address, which makes it much more faster as compared to taking the route of the root DNSserver.com and then coming to Yahoo, and then you get the IP address, right? So for example, if the client wants to get an IP address for www.amazon.com, the client queries the root server to find out .com. So it kind of works in the reverse order. So the request will go to the root DNS, and I will show you there are actually two types of ways in which the DNS queries they work. Iterative and recursive, which I'm going to discuss shortly. But generally speaking, it will go to the root, and the root will tell, okay, here is the .com server. Then you request the .com server, where is Amazon.com, and then to the Amazon.com server, you basically get the IP address of www.amazon.com. Or if it has other domains like sales.amazon.com or purchase.amazon.com or finance.com. So all these the subdomains or the domains of Amazon, the IP addresses will be with the authoritative domain name servers. So the official contact of last resort by the name servers that cannot resolve a particular domain name is the root name server. And root name servers, there are 13 logical root name servers worldwide, and each of these servers is replicated many times. So approximately 200 root servers are there only in United States. So you can imagine how many root servers are there, in the whole world. So, and the reason is this replication so that the load can be distributed, and there is no single server on which the whole infrastructure is relying, right? Now, it is incredibly important that the DNS protocol works because the whole internet function is depending on the DNS. If you don't get the IP address, your request will not be forwarded further. So that is why have been lots of attacks that have been launched on the DNS protocol as well. DNS itself is an insecure protocol that runs over the UDP protocol. And in order to secure DNS, you can use services like DNSSEC, which again, not every organization implements DNSSEC, but once you implement, it will provide you with the authenticity of the messages. The message integrity will also be provided in that case. All right, so as I already mentioned that on the top we have root name servers, then we have TLDs, then we have authoritative name servers. So the TLDs, they're responsible for .com, .org, .jobs, .museums, .uk, .com, .ca, .jp, etc., etc. And the authoritative name servers, they belong to the organizations like Yahoo. So they have authoritative name server for yahoo.com, amazon.com. And then these authoritative name servers, they contain the domain name to IP mapping of their other domains. For example, mail.yahoo.com. These records will be in the authoritative name servers of Yahoo, etc. Now, the authoritative name servers, they are usually maintained by the organization themselves, or they can be maintained by the service provider or the ISP. So if you are launching an organization, your authoritative name server can be placed with your ISP if you cannot have your own authoritative name server. But bigger organizations like Google and Yahoo, they have their own authoritative name servers. As I mentioned that in this hierarchy, the local DNS server is missing, but usually every organization, they have their local domain name server as well. So whenever the host makes a DNS query, it is first sent to the local DNS server. And these local DNS servers, they will return the reply for this name to IP resolution from the local cache. Every ISP, they have their own local DNS. So if you want to find out what is your DNS server, if you're sitting at home, you can check by using ipconfig/all, where you will see the IP configurations, including the DNS, which is probably the local DNS of your ISP. There are two types